studying the electrochemical cells. What is an electrochemical cell? Electrochemical cells, these are the cells in which electrical energy is generated. Electrochemical cells are those cells in which electrical energy is generated or electrical energy is produced. These are the cells in which chemical energy gets converted into electrical energy. These are the cells in which chemical energy gets converted into the electrical energy. Or these are the cells in which spontaneous redox reaction takes place. In these cells, spontaneous redox reaction takes place and decrease in the Gibbs energy takes place. Decrease in Gibbs energy takes place, which gets converted into the electrical energy. This is the definition of the electrochemical cell. First, these are the cells in which electrical energy is generated, or we can write these are the cells in which chemical energy gets converted into the electrical energy. These are the cells in which spontaneous redox reaction takes place and decrease in the Gibbs energy takes place. Spontaneous redox reaction occurs and decrease in the Gibbs energy takes place, which gets converted into the electrical energy. Or these are the cells in which redox reaction takes place in indirect manner. These are the reactions in which redox reaction takes place in the indirect manner, and the chemical energy and the Gibbs energy of the redox reaction, Gibbs energy of redox reaction gets converted into the electrical energy. This redox reaction takes place in indirect manner and Gibbs energy of the redox reaction gets converted into the electrical energy. This is the definition of electrochemical cell. Now, electrochemical cells, as we have known, that is galvanic cell that we use. It consists of construction of the galvanic cell. This is the construction. It consists of two half cells. Electrochemical cell or galvanic cell on the name of galvanic. Half cell, these consists of two half cells. First is known as, this is one half cell and this is the another half cell. This is one half cell and this is the another half cell. In one half cell, I will take this first beaker, which I have used it in the oxidation half cell. It consists of a beaker, and this one zinc rod is dipped. This is zinc rod. We call it electrode is dipped in the 1 molar solution of zinc sulfate solution. Zinc rod is dipped in the 1 molar solution of zinc sulfate solution. And another half cell, it is a beaker. In this copper rod, we call it copper electrode, is dipped in the 1 molar solution of copper sulfate solution. 1 molar solution of copper sulfate solution. In first beaker, we call it oxidation mixture. Zinc rod is dipped in zinc sulfate solution, and copper rod is dipped in its own ions. These two rods in electrodes are connected by means of insulated wire through an emitter. Emitter shows the passage of current. Emitter shows the passage of current. These two rods are connected by means of insulated wire through the emitter. Emitter shows the passage of current, which is opposite to the direction of electrons. The solutions in the two beakers, here it is zinc sulfate solution, and in this beaker it is copper sulfate solution. These two solutions are connected by means of solutions जो है are connected by means of inverted U-shaped tube. Inverted U-shaped tube. Inverted U-shaped tube. This is the inverted U-shaped tube. This is the inverted U-shaped tube. The solutions in the beakers are connected by means of inverted U-shaped tube. This inverted U-shaped tube contains an electrolyte like KCl, KNO3 or NH4NO3. You should keep here in mind that this electrolyte or this solution which is kept in this inverted U-shaped tube should not come in the chemical reaction with any of them, either with copper zinc sulfate or with this copper sulfate. This solution should not come in chemical reaction, neither with zinc sulfate nor with copper sulfate. It should not react with any of the contents of the cell. That means it should be inert. I will repeat it. The inverted U-shaped tube is filled with potassium nitrate or potassium chloride, saturated solution of potassium nitrate or saturated solution of potassium chloride or saturated solution of ammonium nitrate. This solution, either KCl or KNO3 or NH4NO3, any one of the salts we can write. These three salts or these contents of this tube must not come in chemical reaction with neither with this nor with this copper sulfate. This solution is very pure. The solution in this cell, in this U-shaped tube, is prepared in the agar-agar medium, so that to make it a semi-solid. Now, openings of the tube, inward tube, are plugged. Openings of the tube are plugged. Openings of U-shaped tube, inverted U-shaped tube, are plugged by cotton or steel wool. These openings are plugged by means of cotton or U-shaped this steel wool. This inverted U-shaped tube is known as salt bridge. This inverted U-shaped tube is known as salt bridge. So salt bridge definition is, we can define the salt bridge. It is the inverted U-shaped tube filled with inert electrolyte like KCl, KNO3, NH4NO3. The openings of this tube are plugged with cotton or salt bridge. This inverted tube connects the solution internally. It connects the solutions of the two beakers. It connects the two solutions in the half cells. Now, when the circuit is completed and the key inserted, when the circuit is completed, the key is inserted, current flows, flows in the cell which is shown by the emitter. Current flows in the circuit which is shown by the emitter, and following changes take place. What changes take place in the cell? Number first, zinc rod loses weight. Zinc rod loses weight. Here is this one rod. This rod loses weight. This zinc rod loses weight. Whereas, and number 7, concentration of Zn dipositive ions in ZnSO4 solution increases. That is, here Zn dipositive ions in concentration of Zn dipositive ions increase in the cell. Concentration of Zn dipositive ions increase in the cell. Number 3rd, copper rod. Copper rod gains weight. This one, copper rod here. This copper rod gains weight. Copper rod gains weight. Copper rod gains weight. Concentration of copper dipositive ions in copper sulfate decreases. Concentration of copper dipositive ions decreases here. Concentration of copper dipositive ions in the copper sulfate decreases. So current flows. Electrons flow from zinc to copper. Current flows from, as we mentioned, copper to zinc. Electrons flow from zinc to copper, and current flows from copper to zinc. So what happens? We will write the chemical reaction here. Zinc rod loses weight. Here, zinc rod loses electrons, gives Zn dipositive plus 2 electrons. This is called oxidation. So here oxidation takes place. So this is called oxidation of cell. In this cell, zinc rod gets oxidized, and this is called oxidation of cell. So these electrons, which are lost by zinc, pass through the electrode and through the copper, and are accepted by copper dipositive ions here. Copper dipositive ions, these electrons are accepted by copper sulfate, copper dipositive ions. So copper dipositive ions accept these 2 electrons, give copper solid. So this is called reduction. So here, this is called a reduction half cell. This is called a reduction half cell because here reduction takes place. Since in oxidation half cell, this electron oxidation occurs at anode, we call this anode. Oxidation occurs always at anode. Oxidation occurs at anode. So at zinc, since zinc is oxidized, so here oxidation takes place. These electrons pass through this electrode. So here anode is negatively charged. You must remember this. Since oxidation occurs here and electrons pass through the electrode through the wire pass through the copper, and electrons, this anode here, electrons are generated. So this anode here, it is negatively charged. You must not get confused because this is opposite to that of electrolysis. Here electrons are generated and this electron here oxidation takes place. So this is negative electrode. Anode is here negative electrode. And these electrons are accepted by the process ions and this gets positively charged. Now this is cathode, it is positive. Oxidation occurs at anode and it is negatively charged electrode. And reduction occurs at cathode. Here it is positive, it is negatively charged and it is positively charged. So here it is positively charged. So electrons flow from zinc to copper, while current flows from copper to zinc. This occurs the change. So reaction, what happens in the reaction? The overall reaction comes zinc plus copper dipositive ions gives Zardian dipositive ions plus copper solid. This reaction takes place. This is the oxidation reaction. Zinc gets oxidized and copper dipositive ion gets copper gets reduced. So oxidation reaction takes place in the cell. So this is called oxidation. Here oxidation and reaction takes place in separate containers. Here oxidation takes place and in this cell reaction takes place. So oxidation and reaction takes place in indirect manner and this energy is converted into the electrical energy. Here the decrease keeps energy in having negative value because it decreases and electric energy is generated. Rest of this reaction, rest of this electrochemical cell will study tomorrow.